So the way we do this is by this. There are rules. Well, that looks pretty overwhelming. All those tiny little words there, and it looks like 13 rules. And I think if you tried to memorize that, that would just cause you to go insane and it would be meaningless. So what we're going to do is work through some examples, and we will refer back to the rules so you can get used to using the rules. But we'll work through some examples that will help you be able to, on your own, given a formula, predict the Lewis structures, okay? Because when I give you oxygen and ozone, you ought to be able to predict the Lewis structures, and that's going to be able to tell you something about why they behave differently. The first rule, though, I'll point out right here, is hydrogen atoms form only single bonds. So they're always at the ends of a sequence of atoms. So, and also, if you're given a choice, hydrogen is often bound to carbon, nitrogen, or oxygen. So that's just like a little rule, FYI, to keep in the back of your head. And the reason why they only form single bonds and that they're always at the ends is because they only need 2 electrons to satisfy their octet. So if you tried to put something like this together, remember, what is a dash? A dash is really a shared pair of electrons. What is a dash over here? A shared pair of electrons. So this hydrogen here in the middle, if I put a circle around it and counted, there'd be a total of 1, 2, 3, 4 electrons in its valence shell. That's too much. It's too small. It only needs 2. It can only have 2. And so it's not going to be found embedded in the molecule like this. So sometimes we say they're terminal. They're always on the outer edges of molecules. All right, so this would be a terminal situation. There's nothing else bound to it but the carbon. All right, so that's what that first rule means.